Okay, hello everybody. We'll be doing a quick question with some phasor voltages, currents, and components. So I'll do another video on how to do phasor and complex stuff in a calculator. I'll do that separately though. That's coming shortly. For this one, we have this simple problem that asks us to find the average power in each component. And it gives us capacitor and inductor, but gives us the impedances, and we have the source given in phasor form. So what are we going to be looking for here? So the equation for P average power is equal to the absolute magnitudes of the voltages and currents divided by 2 cos the angle of the voltage minus the phase angle of the current. So we need to solve this for each of the 1, 2, 3, 4 components. So we're going to have to do that first by solving the circuit because we need to know what the voltages and currents are. I'm going to label this node V1, call this part V2. I'll label this branch I1, and that's I2. That's just arbitrary. There's nothing specific. You can do it however you want. So what we have here is a circuit with 2 branches and 2 current source. So essentially what you have is like this. I can combine the two j minus 4j minus 3j. So we have this current divider, right? The current through that's I1, I2. So I can use a current divider equation, which if I'm solving for I1 will equal to the source current, so the 2 angle 0, times the opposite branch impedance. So minus 3j divided by the sum of both the branches' impedances, 5 minus 3j. I'll punch this into my calculator quickly. So this is what it looks like. I don't know if it shows up on the camera there. Get 1.03 angle negative 59.04 degrees amps. I can repeat the same process for I2. I2 is equal to the source current times the, if I'm looking at this branch, I'm going to look at the opposite one, 5 over 5 minus 3j. I punch that in my calculator. 1.71 angle 30.96 degrees amps. So I found the currents. Now I need to find the voltages. This is actually pretty simple because if we look at our circuit, what is V1? Well, if I redraw it, 5, if I take the bottom to be ground, I have V1 and I just have I1 going in. So if I have a current, I have an impedance, and I have a voltage, I could just use the Ohm's law to figure it out. So in this case, V1 will equal 5I1. 5I1 is 1.03 angle negative 59.04 degrees. 5.15 angle negative 59.04 degrees volts. V2 we can solve a similar way, where if you look over here, V2 is just above this capacitor. Right, if I label the bottom part ground, I have a current I2 goes through the capacitor, and I want the voltage above it. Therefore, V2 will equal to whatever the capacitor is, negative 4j times I2. Drawing that would be this. I have my I2 and V2. So this will be negative 4j times 1.71 angle 30.96 degrees equals 6.84, angle negative 59.04 degrees volts. So now I found all my voltages and all my currents, so I can start solving for average powers. Let's start with the resistor. So P average is equal to the magnitude. If I look up to my circuit, it'll be V1 and I1. Just inputting the complex number parts from before. I put in, what was that, V1? 5.15 times 1.03 divided by 2, cos negative 59.04 minus negative 59.04. So that goes to 0. Okay, plugging that into my calculator. I can see that the cos is the argument 0, therefore this will always be 1. I get 2.65 units are watts because it's average power. Okay, that's fine. Now let's look at, let's say, the capacitor. P average, this one has V2 and I2. V2, magnitude of I2 divided by 2, cos theta V2 minus theta I2. That will be equal to 6.84 times 1.71 divided by 2, cos negative 59.04 minus 30.96. Well, when you do the math here, this negative 59.04 minus 30.96 equals negative 90. Now, cos of negative 90 is just 0. So that'll be 0 watts. And this makes sense because capacitors and inductors do not consume any sort of power. So actually, I can write for the inductor. Sorry, my camera battery's dying. I need to speed it up. P average equals 0 because inductor. Lastly, we have the current source. This one, we use P average is equal to V1 I source divided by 2. Uh-oh, my pen's dying. Cos theta V1 minus theta I source. So this will be 5.15 times 2 divided by 2 cos negative 59.04 degrees equals 2 cos negative 59.04, 2.65 watts. So that's delivering power, that's absorbing the power. So we see they equal each other, so it works out in the end just fine. If you sum up all the powers in the circuit, the source we assumed is just delivering, so you can change it to positive or negative, whatever standard you want. But we see capacitor and inductor are 0 watts, and the resistor and the source, one delivers power, one consumes. There's no power left over. It all seems to check out. So there you go, and new videos will be coming soon. I got some stuff in the way I get done first. Should be coming by the weekend. Okay, well, have a good one.